This video is going to take a look at what's called the factor theorem and the remainder theorem, and really just a special case of them where we're going to really focus on how they help us divide polynomials. The way we divide with polynomials, at least the easy way, is a method called synthetic division. And synthetic division is probably easier to show with an example than it is to actually describe the steps. So we're going to show it with this example. We're going to take the polynomial 2x cubed minus 6x squared minus 13x plus 4, and we're going to divide it by x plus 2. How this synthetic division is going to work is first we're going to take whatever we're dividing by, and we're going to set that equal to 0, which solves really easily by subtracting 2 from both sides in this case. So x equals -2. The answer we get, we're going to stick up here in what I'm going to call the box. And then what I'm going to do is I'm going to take all of these numbers with their signs and stick them to the right of the box. So we've got a 2, a -6, a -13, and a 4. Then I can leave a space for a line because I'm going to put some numbers above this line. And what I've done now is I've set up my synthetic division process. How the synthetic division is going to work is I'm going to bring the first number straight down. And then I'm going to take the -2 in the box and I'm going to multiply it by whatever number I have below, and that answer is going to go underneath the -6. So in this case, -2 times 2 is -4. And now I'm going to add these numbers going down. -6 and -4 is -10. Multiply by -2 again to get +20. Add again to get +7. Multiply by -2 again to get -14. And add again to get -10. That last number I'm going to stick in another box. And these numbers at the bottom can help me interpret the answer to the synthetic division problem. The last number is my remainder. The number before that is my constant. That means just a number by itself. The number before that's going to have an x on it. The number before that's going to have an x squared on it. And if there are more, I would keep going. X cubed, x to the 4th, x to the 5th, and so on, counting up. The way I can interpret this answer then is I have 2x squared minus 10x and a +7, the sign's not there, but I know it's positive, with a remainder of -10, and that's going to become my quotient when I do the synthetic division. All right, this example I did really slowly, step by step explaining. Let's do another example where we can just go through the motions now that we've seen the process to do another division problem. We're going to do 4x to the 4th minus 15x cubed plus 11x squared plus x minus 18. And we're going to divide that by x minus 3. Just like before, I'll start with that x minus 3, make it equal to 0, add 3 to both sides, and x equals 3 is my number that's going to go inside the box. Then the coefficients for -15, +11. There's no number written. I always know there's a 1 in front of every variable. And -18. Finish out that first row. Leaving space to show my work, we should be able to do the synthetic division from here. Bring down the 4. 4 times 3 is 12. 12 minus 15 is -3. Times 3 is -9. 11 minus 9 is 2, times 3 is 6, 6 plus 1 is 7, 7 times 3 is 21, 21 minus 18 is 3, and I put that last 3 in a box because I know that's going to be my remainder. Going backwards, I know that 7 is a constant, the 2 has an x, the negative 3x squared, and the 4 is x cubed, and so I can see my final answer for this division problem is 4x cubed minus 3x squared plus 2x plus 7 with a remainder of 3. And we have our solution. Now, as we're doing synthetic division, it's very easy to fall into the trap of thinking this is a very simple process once you get the pattern down and you start not paying attention to what's going on. A very important point and a common trap people fall into is they don't realize if a term is missing, we need to use 0 or 0x or 0x squared or 0x cubed or whatever the missing term is to make sure every term is accounted for in our numerator. Here's what I mean by that. If I have 2x cubed minus x plus 3, and I want to divide that by x plus 1, I see that it's 2x cubed. What should come after 2x cubed should be the x squared, but there's no x squared here. So I need to keep in mind that I've got 0 x squareds because those x squareds are missing. Once I account for that, everything else should work the same. I say x plus 1 equals 0, subtract the 1, x equals negative 1. Negative 1 goes in the box. My coefficients then are 2, 0, I'm not missing the 0, negative 1 and 3. And then I roll through the synthetic division. Bring down the 2 times negative 1 is negative 2, plus 0 is negative 2. Times negative 1 is positive 2, minus 1 is 1, times negative 1 is negative 1, plus 3 is 2. And so I can see quickly that I've got an x and an x squared. So my final answer is 2x squared minus 2x plus 1 with a remainder of 2. So as long as I keep track of that missing term, if there is one, most of the time there's not, but they do tend to sneak in there. If I get that missing term, I should be able to roll through the synthetic division process and divide my polynomials without much difficulty. It's your turn to practice a few of these. Good luck on the assignment.